Once again, good evening, all of you, and welcome to this session. So this session is basically on, we are trying to discuss and correlate ourselves with GD&T. Okay, let me just try to share my screen. I hope all of you can see my screen and hear my voice, right? Any SS in the voice, please?
Yes, we can see your screen.
Yeah. Any voice from the participants? Nope. Okay. So I will try to continue. Today's session is called GD&T. So here, what we are trying to see is how important and how it has evolved and how important it is, and how basically it is necessary for us to know about what is GD&T in our daily life, professional life as an engineers of any field. Okay. So in the first slide, I would like to mention that we will try to go through the history. History is very important because it gives us the depth of the evolution and the importance of the subject, which has gone through these sessions. And then afterwards, we'll try to learn about some of the symbols, and then we'll try to put up the application. Somebody is telling it's not audible. Is it audible, sir, now? So my mic is not on mute.
Vinay, you are audible. Yeah.
Yeah. Yes. So let's go and know what is GD&T. Let's go into the history first. Okay. So way back in 1939. 1939 is where we had the Second World War also. Way back in 1939, Stanley Parker, a person named Stanley Parker, was known to be responsible for starting off this GD&T. Okay, so he was working in Royal Naval Torpedo Factory in Scotland in 1939. So what is this torpedo factory? Torpedo means it is a kind of a missile which can be launched from a submarine or a ship for underwater. It propels itself. So then at that point of time, war was going on, and he was trying to manufacture lots and lots in millions. And he has to supply for every day of use in every day of the battlefield. So, but when he tried to manufacture this, and then when it was getting checked by the for dimensions and other things, he found that some of the most of them, about 30% or something, were rejected, and only 70% was accepted at that point of time. So he was wondering, because this whatever is rejected is just sitting on the floor, and there was a huge demand and cry from the on the war front, and then he didn't understand why this is happening. Okay, because functionally it was functioning, but it was not acceptable. So then when he tried to analyze some of the geometries and its dimensions, try to do some measurements and all that, and he found out that the tolerance of that part, I mean the tolerance, it means the allowable tolerance on the part, was laying on they were using something called as a square tolerance zone. Now, what is a square tolerance zone? When you have a part, when you have a rectangle, for example, and you are giving dimensions of length and width. So when you give the tolerance there, when you see the tolerance zone, it is from the left to right and top to bottom. So it becomes a square. So he was seeing that a lot of geometry tolerance was on the circular pattern. So when he's drawn a circle over the square tolerance zone, and he found out that 57% of the tolerance zone was available, but they always said that was rejected. So the true position, is one thing which Stanley Parker, it goes with the Stanley Parker name. The true position is one So he, by this, he could always prove that 57% of his products were just rejected, but they are all functional. Okay. So let us come to the second page. We will learn about the history of GD&T. So way back in 1935, when the military rule was on high, the military people were doing a lot of defense products, a lot of things. They were trying to find out and write a book of how this things can be drawn on a drawing sheet. What is the rules to be used so that it is acceptable. All the components are acceptable about 70-80% of the components. So they merely started with few of the variables. It was a 35-page long. It was only by the military. So way back in from 1935 onwards, when we come to 1946, what happened in America is that the automobile industry also grew. That is the domestic transport of vehicles also improved. So what happened is, at this point of time, the automotive industry also said, hey, look, we also want this GD&T. We also have so many parts manufactured, so many parts in different parts of the country and the world. And when they came to be assembled in one place, so so interchangeability, like you have a nut made in some other country, bolt made in some other country. When you bring it to your country and then you do it, the interchangeability means what? One part, any part just picked and assembled, it should assemble. So that was not happening. So that is the main thing why GD&T was growing. So way back from 1946 to we coming to 1946, there was another society in America, Society of Automobile Engineers. They released a book which is 135 pages. Please remember, from 35 pages we are now up to 135 pages of really how a part should be defined. A part which is going to be assembled has to be defined. So it's a quite a long journey. And today, this is why we are trying to touch upon this point, because this really gives us the amount of effort, amount of research they are putting to this. And at the same time, it also tells us how important it is to know this. So in 1949, they released one more book. It is called as a MIL standard, that is military standard again. And they also stated rule number one. Rule number one is very simple. When you have a cylinder which you have dimensioned as height and the diameter with some tolerance, the shape is governed by the tolerance limits. Like diameter is 10 plus or minus 5, 10 plus 5 or 10 minus 5. That tolerance zone will define the size of that part. So coming back again in 1952, the same SCE people, Society of Automobile Engineering, they also released one more book. And in 1953, the MIL standard, they adopted one more book release. And most importantly, in 1957, Association of Automobile Engineers in America, they joined hand with British and Canada. So these three countries came into a kind of understanding and how to do this dimensioning and give notes. And they call it as Y14.5, where 14 were the number of symbols and 5 were the number of categories, as you know. So that was way back in 1957, please remember. In 1959, again, they released one more book. So we have started our journey from 1935. So we have come up to 1959. So in 1963, and they released a updated version of the book released. And what we use today is what you see now. It is a comprehensive standard for US, British, even ISO, and Canada. Single acceptance. They have the military standards and the industry. They have accepted this. So what we use now is Y14.5 to 2009 is what is available with us. So why is this? I am going to give you history. The history, why I'm trying to tell about the subject is the deep history. The history will be just created when there is a need, right? So when there is a need, there will be history is created. And when there is an importance, of a certain subject, then the history is created. So that is why we are into this era, and it gives us a strong message that every engineer who is doing any kind of a manufacturing assembly or inspection operation as well as design, it makes it a mandatory thing that this is known. So since it's been for a long time, the industry also accepts that these things are known to any person who is entering into an industry for his new career or anything. So that's why I have made this few slides for you, just to give a depth of this history. So let us continue. The next slide is very important. This is a slide which will tell you about the domains, the domains where this is used. So first thing is the design. So design is also a domain where a concept, the evaluation of a concept, evaluation of an idea is generated.
Sorry to interrupt.
Yeah.
Can you increase your volume a bit, because I'm getting a lot of comments that they are not able to hear you.
No, it is 100% on my system. I don't know whether I have to increase my own voice. I'll try to increase my own voice.
Yeah, thank you.
Okay. Thank you. So I'll try to increase my own voice. Okay. So design is a field, as you know, as we are engineers, that design is for engineers. So like a requirement is converted into a kind of reality, and this reality is then designed or kept in front of you in form of a electronic media as a CAD or any other media as a drawing and a paper. So this field, wherever you see you have applied, or any industry you are going into, or any professional you like to be a designer, this is a kind of a mandatory thing that we know what is GD&T. Okay, so we'll come to GD&T a little later what it is. I'll just give you a brief of it. It makes us very important that the output of a designer, where it is fully defined, it is called. So the design domain also makes it very important. Next, so the next important thing, like if you are a normal product designer or any of that responsibility you are taking as a draftsman, even as a draftsman or anything. So this is something which you have to keep in mind, because you have to ultimately define what your product or your design is trying to do, or it is trying to communicate. So next domain is the manufacturing domain. The manufacturing domain is a big domain. So the word manufacturing says that whatever is designed now, so what is the requirement of the raw material? There is a raw material like aluminum or steel or copper or anything. So this raw material is now converted into the manufacturing part. So once the design is done, it has to be manufactured, right? So once it is manufactured, how do a designer makes a manufacturing people understand the way the designer wants? See, here the most important is way the designer wants. So designer will sometimes give a drawing and the manufacturing will do something, and it will look similar, but it will not be same. Similarity will be there, but not the same. So that barrier will be there. So the manufacturing here, we are concentrating on manufacturing of assembled parts. See, individual parts, it's okay. And a small parts of 2 to 3 is okay. When we say manufacturing assembly, which has got more number of parts, especially these parts are manufactured globally with different vendors, and there you are trying to assemble it in one place with lot of iterations. So there should not be any kind of confusion or kind of mismatch, and the rejection should be very minimal. So this is one area where the manufacturing, if you are taking up a responsibility or taking up a career in any manufacturing industry, so we should not say it becomes handy, it is a must. The subject knowledge is a must. So when we come to the other part, that is called as quality. Quality is also one of the large domain, where any part which is designed and manufactured or assembled, it has to be validated, right? Somebody has to say, yes, this is correct, this is right, so go ahead, this is correct, now you can manufacture it in millions or thousands of numbers. Okay, so quality is one of the domains where the any type of kind of design validation, design inspection you are doing, so you need to have the knowledge of GT&T to understand what the designer is trying to tell you and the manufacturing people have manufactured and how it has to be inspected. Okay, so this is also one of the major things. It's a very, very, very vast field, and that makes us tell that, you know, this is required. To give a very layman's example, so we normally use I'm just giving you a very layman's example where, you know, we used to, whenever you communicate between anything, human to human or anything, when you communicate, the language becomes very important, right? So the language is something like a drawing sheet. So the language becomes very important, whether you are using English or any other regional language, the language becomes very important. Now, when you're talking the same language, we normally hear that, you know, some people don't understand my English. So what we do is we try to use English language with something called as a grammar, right? So if your grammar is right, then the understanding is right. So the grammar dictates a lot of things, right? In a language like present tense, past tense, future tense, so many things. So it is same thing like that. A drawing sheet conveys what your drawing is, views and other things, but how it has to be done, how it has to be look, what is the functional requirement, what is important, what is not important, lies with the hands of a GT&T technique. So you are getting my point, which is quite clear for you how important this is. So these are some of the domains where you can normally we should have this. Your first couple of questions will definitely be on this if you are on all the three things. So now let us do one thing. Let us get, these are the two, when I just finished with my history, and then I finished with my the vast umbrella of opportunity or industry which needs this. Now let us go into a little bit of knowing what is GT&T on a very superficial level, so that it makes some sense. The next slide is called geometric tolerance. When anybody asks you what is geometrical tolerance, sir, so then you can find many of these things with your handy, with any of the books and other things, even in the internet and all that. So what I have highlighted in yellow, let us keep some concentration on that. The highlighted on yellow. So engineering drawing, everybody knows. It is an international language, everybody knows. But what is GT&T? Accurately describing a part. Okay. So accurately describing a part. So I'll just give you one more example. If you want to tell your kid at home what is an apple, if you draw an apple on a page, how it looks, or if you just give an apple itself to your hand, how it looks. So that is the understanding. Okay. So you have to accurately defining a part. How do I accurately define a part to a child? I just gave an apple to his hand. So when he sees an apple in his hand, so it is accurately defined. The child will not make a mistake of picking another apple to an orange. But if it is done on a drawing, a plain sketch, it might sometimes say, okay, looks like an apple, something like that. Okay. Now coming to the next thing, it is a philosophy. Okay. It is a philosophy means what? Just because I know GT&T, I don't have to really put everything everywhere. So it is a philosophy. It is a philosophy which is gained by some of the industry experiences or some of the thumb rules which have been proved by the industry to give this. How it functions in the final product. So whenever there is a function, so GT&T is applied to a part where it functions. It's not applied to everything. Okay. For example, if you take a pen, the cap and the body may be very well designed, very attractive, everything. But if the cap does not fit or does not stay in place when it is closed, then, you know, the pen, however it is it may not do its function. So its function of the cap is to retain onto the pen. So that's what I want to say. So let us continue a little bit. Okay. So this is what you should remember. GD&T is not more than just symbols. It is just not symbols. It is not symbols. It is a kind of a commitment. It is a kind of a communication which you give. It is a kind of a technical communication on the drawing. What is the flow? It flows from design to manufacturing, and manufacturing to how it has to be inspected. Okay. So when you see that here, in a normal scenario, we always have barriers between the design department, manufacturing, and inspection department. We always have barriers where they are confused, or they don't understand, or they don't inspect, and which will require a lot of cost. If it is a design phase, you will have X amount of cost. If it's in the manufacturing phase, it is in a X10 cost. And if it's rejected by inspection, it is 100% cost loss because you already have manufactured it. Okay. So that's what I wanted to tell. Now let us go to one more slide just to try to make you of a superficial understanding. See, there is something called as general dimension and tolerance. So general dimension and tolerance is what we are trying to be using all these days in our engineering, diploma, ITI, everywhere, that we always give dimension to all the parts, say that, look, my part is fully dimensioned. So what happens to the general dimension tolerance? It controls the size of the part. It controls the size of the part. What do you mean by controls the size of the part? If I want a shaft of 10 dia with 100 mm length, yes, I have it in my hand. But what does geometrical dimension tolerance control? It controls the shape of the part. I have a cylinder which has got a diameter of 20 and a length of 100. Good. But now the cylinder is bent. It is not straight. It is now bent. So according to the first general dimension, it is okay. But it is bent. It does not serve my purpose. So now the GD&T will control what is known as your shape. So let us run through some of the cases what I did my mistakes when I was in manufacturing. In case number 1, I just gave 20 dia, 20 dia. I wanted a shaft going into a hole. I said 20 dia of the shaft, 20 dia of the hole. So when it got, I said, I want 10 pieces of this. The manufacturing guy manufactured and gave it to me. And when I tested using some instruments, it was always 20-20, but it never went inside. Okay, because at certain cases, the hole was small, shaft was big. The shaft was small, hole was big. Something it is like variation. So I thought, okay, then there is something wrong. So in the case number 2, what I did is I put some tolerance. So these tolerances are called limits. Limits of the size which can vary. The size control. I'm just doing the size control. I'm not worried about anything else. So here I mentioned 20 plus 0. That means I don't want the shaft to go above 20. And I don't want to go the hole to go less than 20. Then I thought all the shaft will come in place. So I gave an order for another 10. So what happened is, since now after giving this, still I found that 30% of my components were not fitting. So what is happening now? The surface of the cylinder was wavery. So in some point, if I measure, the diameter is going above 20 and some point it's going below 20. Whenever it goes above 20, it means the shaft will go half inside and half it gets stuck. Then you try to make it forcible, and then that does not allow the purpose. So that was the problem. So in order to avoid that, what I did is, in the case number 4, I added some of the geometric tolerance. Like, I added A, which is a datum, which will from where I have to be measuring. And I had a cylindricity of 0.02. So 0.02 is a tolerance on the shape of that thing. So now I found out that almost 90% of my component were accepted. So that is what I wanted to give a gist of what is GD&T in this slide. So next we will do one thing for the what we'll do is we will just go through the symbols quickly. We'll go through the symbols. I said 14.5 na? So we'll just go to the 14 symbols. I just wanted to highlight and educate that how it has to be read. because reading is also very important. That is, interpretation is also very important when it is given to you. So now let us take the first example, very simple one, which is called straightness. So now if you see my screen, from left to right, I have made it into 4 sections. The first left-hand side top corner, I have given you the symbol. So what is the GD&T symbol for straightness? It's a straight line. The next point, what we have to remember is related to datum. No. That means what? Do we require any kind of a reference to measure it? No. It says straightness does not require a datum. What do you mean by we don't read a datum? Datum is nothing but we are taking a reference. The first slide I will try to explain very detailedly, and then we can go through the other slides when it is designed in the same form. So we can go straight. On the right hand corner, we have said form in green, FORM form. Okay, so straightness controls the form of an object. Why do we say datum we do not required? When you are sitting in your home, you have a table in front of you. Okay, the table is flat. It is straight. It is flat, straight. So whenever you measure in a straight line using some instrument, you are happy that it is straight. Now this table, if I rotate it by 90 degrees and keep it, the straightness will not change, right? The straightness will be there itself. That means it is not related to any datum. Okay. So next point is what we normally call as MMC and LNC, when it is very clearly, very nicely designed and explained to you in our courses. So maximum metal condition and least metal condition. Maximum metal condition means what? Still the material is there for you to repair or do any correction. So that is called the condition where the maximum metal condition means there is a material where you can actually, if you are going off too much, you can make a bit of repair in a certain areas. So that is called maximum metal condition. If you take a hole, the minimum size of the hole is maximum metal condition because metal is still there. If you take a shaft, the maximum size of the shaft is taken as MMC. Okay. So that we will, when you take up our course and other things, it will be very well explained. I'm just giving you this. So how this is, these next most important, what you have to focus on learning in the course is that how it is interpreted on the drawing. How it is interpreted on the drawing. So if you see in the interpreted drawing, there is an arrow, there is a box. There is a couple of box in there, and there is an arrow. Arrow says that where it is applied, and the box is called as a frame. So this frame will tell you, the first frame will tell you the symbol, the other frame will tell you 0.03. 0.03 is a unit of deflection. It is not plus or minus, it is a band. Please remember, it is not plus or minus, it is a band, 0.03 band. From the surface, what you have, we take the band 50 up, 50 down, generally. Okay. On the right hand side, you see that the two parallel lines, the blue color lines is what is allowed. The red color is what is the actual. When you measure and write a profile of the surface, it looks like that. It is quite exaggerated. Okay. And the right side corner down is what is most important, is how it is measured. So since it is a straight line, it is always measured in a straight line. The cylinder has a cylindrical surface, but it is measured on a straight line. So this is what I'm trying to give the importance of learning curve on the GD&T. So next one is the same straight line. It's the same straight line, but look at the bottom left corner. It is connected to a dimension. So previously it was connected to a surface, and now it is connected to a dimension. When it is connected to the dimension, it takes the center axis. Okay. Right. So we will try to now, from here on, we'll try to move a little faster, because you have understood that what this is. Okay. So yeah, 0.03 is just an example. It is not compulsory. It depends. It depends upon the tolerance. What you require, how stringent you require, how more you require. Okay, right. So next is the flatness. Now that straightness was for a single line, flatness is throughout the surface. Okay, same thing here. How it is called out on the drawing, what does it mean, and how it is measured. Okay, so when the designer is put on the drawing, how does the manufacturing guy look at it? It's on that diagram. How the inspection guy inspects and tells you that, okay, whatever you have done is right, is what is in the right hand side. Okay, so these are different symbols. This is circularity. It's a 2D. Circularity is 2D, as you see. At any point of time, any point of section of a cylinder, when you measure, the circularity is that measure. So the red one is the actual, the blue one is this. Again, as everybody was questioning, 0.030 is just a requirement, an example. If you want more stringent, you can make it small. If you want more reliable, you can make it big. Same way we have what is known as cylindricity. I'm just running through all these things. This will be very elaborately with examples, with challenges. Everything will be given in our course to you. Okay. So then we have parallelism. So how it is parallel. Okay. Now here, when it say parallelism, one change you can see, it says that relative to datum. Yes. A parallelism is always measured with a surface. On the right hand side bottom, if you see that flat datum block A, a flat datum block A, a block, what you want to measure is kept on a table, a surface table. Okay, so that means what you are generating the datum first, and then you are measuring it. Okay. Same way, your perpendicular also you need a datum, how it is measured. Okay. So these things, what you see, different pictures like M, A, everything will be taught to you in our course. This is for angularity. Okay. So angularity affects your orientation, also your form. And there is in GD&T also we have something called as hierarchy. Some of the symbols take priority. They cover up a lot of things. Profile is one of them which covers a lot of things. Position and all that. So no, so there is a kind of a hierarchy which will be told to you, which will subside or it will automatically take care of other symbols. Profile as a line, profile as a thing. Okay. And the position, the true position. This is the what the Parker had told you, right? The true position of a hole. Okay, the position. So somebody is confused about straightness and parallelism. I'll just tell you very simple. Straightness is something measured. See, straightness is measured when the surface is quite straight. Okay. I think I don't know about the sound quality. My mic is all full volume. I also am shouting in a room, but yeah, I am talking very slowly also so that now people understand. So we'll take the questions a little later. Okay, so angularity is one thing. Put my mic very close. Angularity, okay, and so we are talking about profile. Profile is a higher order thing which covers a lot of other lower order things. So true position. Then you have concentricity. Now concentricity is now taken out from the system because we have a run out and parallelism. Then you have symmetricity. Then you have run out. Since we have run out, we have been taking out that concentricity. Total run out is this thing. So I'm just trying to run through this because this is where I want to make sure that how you read it, what it means and other things, and how it is used, where it is used, how it is applied. All this will be very very detailedly told you. So after that, after finishing this symbols I just glanced you. I never explained each and everything. but I just told you how you should interpret and read. After this, we have got two examples. We're just taking two examples, some basic examples, just to tell you how it is. Okay, the first example is very simple. The example is in front of you. It's a flange. So this is a drawing which I have done, and I'm trying to I know a little bit of manufacturing and a little bit of drawing. I have done this drawing and I'm trying to put it across to the next stage. So what we see in this drawing is, okay, from left to right, we just observe. Or first thing what we should do is in a drawing is all the dimensions are there. If you see here, there are some dimensions which are missing. So missing dimension, which is the first culprit, we have to find out. Okay, so there are some dimensions which are missing in this. That's why I am not ready to give this drawing to the next stage. So missing dimension could be that I have not designed it, or I have not thought about it, or I have not seen the legacy part and then transferred it. So many things are there. So this is one of the dimensions which are missing here. So I have given it as dia 64. Then if you see that, this is very important, sir. See, when we see this drawing like this, what is really understood is that, sir, this is a center line. There are 4 holes. By default, I will know that these 4 holes, 360 divided by 4 is 90 degrees each, and they are 90 degrees apart. This is a center line. So this is exactly at 90 degrees. So that is exactly what we do. This is the most things we do normally assume. So what GD&T tells us, don't assume. Please don't assume. So there is no gap for assumption. So GD&T tells me that no, you have to give a 90 degree angle. You have to say 4 into 90 degree plus or minus 5 degrees, you can shift. So by this what happens is, the one thing is it is in 90 degrees. One thing, the manufacturer will also feel that, okay, if I'm out by 5 degrees here and there, okay, then also the part is accepted. So two-way, it is a win-win situation and understanding. Okay, so you said it is 90 degrees. Okay, it is 89 point something. You can take it. Now what is there? The manufacturing will tell. But now it is very clear that, okay, 90 degrees plus 5 degrees, 95 or 85. I don't want 84. I don't want 96. So like that. Okay. So now we have the bottom 2 dimensions were missing. So what I did is I put a dimensioning method which is known as chain dimension. What is a chain dimension? One dimension is the other dimension is following the previous dimension. So 12.7 is there, and if I put one more dimension, it is 12.3. 12.3 is following the 12.7. So that becomes a change way of dimensioning. In the drawing classes, you have understood what is the chain dimensioning. So what happens when we do a chain dimensioning? So chain dimensioning, what happens is the 0.2 and 0.05, they will get accumulated because there is a straight line. They're in one straight line. So maybe 0.05 plus 0.2. The overall is 0.25 can be accepted sometimes. So that means there is a tolerance stack up. So there's another concept called tolerance stack up, which will also be you will be learning in our course. So stack up means what? One above the other. So one above the other. We want in a bracket, we want to set up 10 parts. When we assemble, only 9 is going, the 10th one is not going. Why it is not going? Because all the 9 have tolerances which have been building up. Okay. So to avoid that, it is recommended that we give what is known as single reference dimension like this. Here it is not accumulated. So going ahead with this one. So are we done now? We have given all dimensions, sir. Everything you said 90 degree, everything is given. We are done. Let us just give it to the shop floor. Okay. So let us see if it is done or something is really missing. Yes. What is really missing is we are not defined the center of all the holes. See, there are so many circles here. How are we sure that all the centers are laying? Sir, we can see in the drawing, no, sir. All the centers are center. No. When they manufacture it, they will not come to the center. They will always be left, right, because all the operations are not done in single phase. Some of them are done in lathe, some of them are done in milling machine, some of them are done in drilling machines. So whatever is cost effectiveness, they do it. So when they do that, and if they are not selected the proper sequence as told by the GD&T. Now GD&T is not here, so I can do my own thing. I can do this one drilling first, then turning, then whatever it is, depending on my use. Then what happens? The center will not be at the center. The center will get shifted like this. So when the center gets shifted, what happens? You might get a job which is like this. So in this one, what happens is, if the center shaft is going, only 3 holes are going, the 4th one is stuck. I'm not able to put the bolt, something like that. So, okay. So now that means what I have to do, center lines and center points do not have tolerance by themselves. They are only indicators. They don't have tolerances. Okay. They don't have any this thing unless you provide it on the geometry. Every feature of size must be located. What is feature of size? Every feature, no? If it is a circle or a square or rectangle, whatever you do on your CAD or you do on your machine, it's called a feature. It should be located. Located means what? It should be positioned. Now we are not telling about how the size is, but location. But we should also remember that tolerance is not that required for function, and it's not. If it is not required, it is only required for function. It is not. You should not tighten it. Sir, I gave 1 micron, sir, he is not able to do it. There is no facility to do for 1 micron, or if it is there also, it is huge cost, right? So you should not do that also. So depending on the function, you can do it. So as you can have a question that, sir, I don't have experience, how do I do this tolerancing? You always have what is known as, in any industry, if you go, you will always have what is known as general good manufacturing practices. They will have a document, good manufacturing practices. In that, they will have given you some rules and regulations, how to start, and then you have your own requirements. Now I am putting the center dimension, dia 64. I'm telling that there is a position tolerance of cylindrical tolerance of 0.2. That means the center has a cylinder. Within that cylinder of 0.2 only, the center axis can move. With respect to what? He wants it with respect to B. B is the internal hole. Okay. So the outer hole should be in line with the internal hole to do this. By this, what happens is, even the wall thickness is also maintained properly. Same way, we should also arrest the centers of the small holes. So by putting required geometrical positionings, and we are defining the datums. Okay. So briefly, I will tell you what we should do as a stepwise. See here, what happens is 4 into 90 plus or minus 5 we are given. That is also, there is already a deviation of 0.5 angle, and then we are also giving a position of 0.1. Okay. So sometimes what happens, it becomes very rigid in this. So what we do is, we say that, okay, 90 you can maintain as in the square bracket. That means when you put it in a square bracket, what does it mean? That means that unit will not have any tolerance, or it will follow the general tolerance mentioned in the bottom of the drawing. And above that, 0.1 will be governing. So once we are done that, sir, we have to given everything, no problem. Let us give it to manufacturing guy. Are we ready? Are we done? So let's look at the other side. Are we done or not? If you are done, we'll see yes, no. If it is not done, what is that? Sometimes we have to redefine the orientation properly. Okay. So we thought, okay, everything is done here. We can give it to manufacturing. But thing is, when it is manufactured, we have forgotten about the orientation of this axis. This orientation. See, axis can be tilted, but it can be within the cylinder, right? So orientation of the axis we have forgotten. Once you forgot the orientation, what will happen? Your part will be all correct here. But if you look at the orientation of the single circle, it will be out. That means the wall thickness of that is not maintained, and the wall thickness will be a area where it will be stressed more, so it becomes a weak point. Functionally, again, it will affect when it is doing, if it's a coupling, you may not see it immediately when it revolves or for a certain period of time. Then you will see, okay, no, this is going somewhere else. It's failing. So that means you have to, then here what he has done, he has put a perpendicular symbol telling that bus, this is perpendicular symbol is given to the dimensions. The perpendicular axis should be in perpendicular to the axis. So if you have done this, okay, now we are great. We have done everything and we are giving it. It will be manufactured superb. The only last thing what we are going to refine is, since we want the datum A, A is a primary datum. When we want the datum A to be perfectly fine, we are not defined it. So he will do, okay, you want datum A? No, we will do it in a milling machine, which is rough. It is not this thing. But you are thinking that in your mind, though, this will be milled and then it will be grinded. So when it is grinded, it is within the tolerance of 0.01. With the tolerance, grinding tolerance is can be maintained at 15 microns. You will think that. But the person who is doing this, he will do a milling and then keep it. So what will happen? Your datum surface will have wavery. When it has wavery, it might give faulty dimensions in the when the inspection people are doing it, and they might reject this part. So for this part, finally, what we are going to do, we are going to give a flatness and saying that, yes, I want this to be flat. Now, when I say 0.05, the manufacturing guy will think, no, this can be only achieved by grinding. So I will do the grinding on that first. Okay. So this is one of the examples. I'm just trying to give you step by step, just to give a insight to how it is. So your learning curve also will be like this only. And the course so designed on a real-time experiences and challenges will also take you through. So before going into your questions and other things, I just have a very small one more example. Okay, let's go to that. And we'll have some points here. every feature on a drawing must have size. You know what is the size? It is the diameter, length, and location. Location means the center point should be in the center. Orientation means what? It is in the center. It is not tilted. It is perpendicular. And the form is what? Is it straight? Is it not wavery? Is it in a curve shape like that? So GD&T is the basic rule which controls this 1, 2, 3, 4. SLOF, size, location, orientation, and form. When all these three are given, there is no confusion, and the manufacturing people will take extra care. And these are given only for functional areas. You should not give it for everything. Everything, if you give it, it can be achieved, but the cost will be more. Functional areas. So ASME 14.5 is one thing which governs this. Okay, location is a must, and it is commonly missed. Okay, so there are primary datums and all that. Form stability and primary state datum is very important. The primary state datum will always give a stability to other datums. That means primary datum is first synthesized, means the job is kept on the table on that surface, and it gives stability to all other measuring datums. And finally, we should not be crazy. Since we are overloaded, we know a lot of things about GT&T. When in an interview or something, they give you a part and say, where can we apply GT&T for this part? Normally, it will be a kind of a shaft or something, and then you should be able to find out how to find out. So the steps are very simple. The guidelines are very simple. First, you list the functions of that part with respect to assembly. Okay, not the individual part. Individual part can be anything. Okay, function of the part with respect to the mating surface and mating. First list out the functions. So now once the function is done, you apply GD&T. First, before applying GD&T, functions are there. How these functions are measured with what reference? That is the datum. First functions, then you put datums, references, then With respect to datums and functions, you apply whatever conditions you want. So these are the primary things which are the flow lines the industry will follow and do it. So before we close and take up your this thing, I want to show you one more last example of mine. So I think everybody can see my see my drawing. I've created this simple drawing. A simple drawing where you have a plate, a steel plate. Okay, this is the steel plate with a dimension, length, width, and height of 20 mm. So that is there. Now please concentrate on the operations. One is we have to create the block with length, width, and height. Number one operation. Number two operation is we have to create 4 holes. Number three operations is we have to create a big hole in the center. So there are 3 operations to finish this and 3 high-level operations to finish this. My question is, after doing what the manufacturer is asking me is that after doing the block, should I do the small hole or the big hole? The question is, the manufacturing guy is asking me, should I do the small hole or the big hole? So if there is no GD&T, you will say, whatever is convenient for you, do it. I want it in dimension. That's what you will tell. And the manufacturing will say, okay, I'll do it whatever I want. I'll do the big hole first. Then I will do the 4 holes second. Okay. Then you find that when you are going for assembly of this, stacking up of this thing, that middle hole is not matching side hole is not matching middle hole. Some parts can be this thing. So that if you see very carefully about the 2 frames here, there are 2 frames given here. So I said functions. I said datums. You please see the datum A. Datum A is given here on the right hand side, and it is at the bottom. Where is the datum B? In front of you. Okay, where is the datum C? In the left of you. So first I have to prepare the bottom surface. Then I have to prepare the front surface which is in front of you, and then the left. First I have to do that because I have to generate or I have to synthesize what is the datum. Then I go to holes. The diameter of the holes is only drives by when it comes to operation, you see. So 12.5 drill is available, but 22.2 drill is not available. Then it depends upon whatever the step drill and whatever they drill to do, they do reaming, all that boring operations. Let's not worry about that. So let us see here. If I want to do the center hole first, let me understand. If I decide to do the center hole first, it is at a distance of 47.6 versus 18 from this hole. Here only I got caught because the center hole, if I want to position, if I want 46.6, it is given by this other small hole. There only I got caught. Oh, if I don't have the hole, no. Then what will the operator will do? Nothing, sir. 47.6 plus 14 you add, sir. You will get no. You do center, what is there? He will tell. Okay. Then the 14 mm is here, down. 14 added to 47.6. Okay, you add it and take it. You got the center. No. Okay, did I get the vertical position? No. Okay, that is also very easy, sir. 18 plus 18 mm here, yeah, 16 mm you add, sir, then you'll get it. That's all. What is there, he will tell. But the designer requirement is different. Let us see the frame. 22.2 is the size of the hole. The size of the hole can vary from 0.2 plus or minus. Okay, it can be 22.4 or 22.2. Okay, plus or minus. Now, look at the frame bottom. The frame says first one is position. It says a diametrical value of 0.02. So there is a diametrical value here in the center of the circle, which is at a 0.2. Okay, understood. What is M? M is the maximum metal condition. That means this condition is applicable when the hole is 22 point, the least condition, that is 22.2 minus 0.2. Okay, so least because the maximum metal condition. It is measured with respect to A. It is measured with respect to the bottom surface. Bottom surface you already have kept it on a surface plate. So you already there. You can measure it with using the instrument, height gauge with the vernier, height gauge with a dial or a coordinate measuring machine, whatever you have in an industry. There's one more thing called as D, datum D. Okay. So now datum D, if you want, you should have this hole, right? The small hole, because the small hole is given as datum D. That means it clearly says that the small hole has to be tackled first. Then only I can go for bigger hole. So my sequence is already fixed. So the smaller hole says that there are 4 holes of 12.5 plus or minus with the central tolerance of this much in a maximum metal condition with respect to A, B, and C. A is the bottom, B is the front, C is the left. So if I use a dial gauge with a height gauge, if I measure it from all the 3 sides, if I measure this B as straightness, and if I take it to the center, or if I use a coordinate measuring machine, which will give me all the 3 drawings at one stage. So now what we understood with this drawing, the GD&T, what the product designer has done is guiding the manufacturing guy how to do it, and the inspection guy how to measure it. So GD&T is something which will guide this. So this is what I have done here. This is a raw material which looks like this. Then the bottom A is machined first because it is A. And we go to bottom B, which is the front side I told you. We're going to machine that and generate. Okay. Then we see the bottom C, datum C we are going to generate. Then we are going to do the smaller hole. And then with the reference of the smaller hole, we are going to the center hole. So I think you got a gist of it. So what is covered in my topic tonight as a bootcamp is that, let me iterate before I take into some chats here. First thing is it has gone through history. So history tells us how important it is. So it is a must for engineers to have this course, have this knowledge. It's a must. It's like a drawing. And this, as I told you, language without grammar, language with grammar, history. Then we know that there are some symbols and other things which you have to learn how to apply. Then we saw that what is the conditions to apply. It is only for functions. It is not meant to be just given randomly. Like, you know, if you are a beginner, give everywhere you want. If the interview person asks why you have not given GDN to this, you might say that, sir, this is just a bolting point. It doesn't need anything. Okay, like that. Because by that you are easing the manufacturing guy, also inspection guy. Then we saw one example where when step by step we try to see, it is an iterative process, right? When you go on checking that this is missing, that is missing. Please remember, interchangeability is the most important word. Why GD&T is applied? GD&T is applied only for assembled parts. Interchangeability means what? I'm not putting pen and cap this thing. Same parts manufactured all over the world. If I get 50 parts from China, if I get 50 parts from India, and if I get 50 parts from Russia, so I take any one from any bucket and just try to assemble it. It should assemble. Okay, it should not say, oh, China is good, only China you use. Only Russia is good, no use. Only India is the best, don't use. Not like that. Okay, so it's like everything should be same. How do we control this huge numbers with everything same is from GD&T? Okay, so that's what it is. I'll just click on the chat. I don't know, it's like, so I mentioned is at datum D, right? So it is not XYZ. What is not XYZ? So datum A, see what we use as ABC number here is A is a primary datum, B is a secondary, C is a tertiary. Okay, that's what it is. GD&T books, you want to see that slide? Huh? Okay, I'll go through it. So we are having a lot of questions here. Okay, we have got a lot of questions here. So what I'll do is I will try to answer them by in the forum or something, so that it can be answered. Okay. Yeah, I don't know about my voice here. Really, I'm very sorry. I have the best internet, voice, everything.
Sir, your voice is clear. No issues.
No issues. Huh? Okay. Okay. Fine. Thank you. So there is a lot of questions here. We will take it up, but I think I have made my gist clear. Why GD&T should be a part and parcel of your knowledge base. Okay. So do we have how to measure perpendicular tolerance? Very nice. See, perpendicular tolerance, how to measure is, I don't think whether you have done this in your engineering thing. So we had something called as slip gauges, and we had something called as perpendicular block. So we are trying to make the perpendicular surface horizontal and then try to measure it with in the engineering level. But now that we have a coordinate measuring machine, it gives you with no time. We just have to if we have to make the datum face to be there. And perpendicularity, don't confuse it to the 90 degree. Okay, the 90 degrees can be maintained, but it is shifting. The 90 degrees is think of like there's a 90 degree angle line which is shifting left and right. That means within a band it is shifting. Okay. Somebody wants to see the GD&T books. I will also show it to you. Yeah, there are a lot of questions here, and I think I myself and my colleague will try to put it on the forum. Okay. Okay. Somebody wants to see the books. So the datum D, if somebody was asking me here, datum D is nothing but the center axis of the hole. Let me go to the drawing. See, datum D means what? See, when they say datum D in this, somebody is asking, where is the datum D? It is not a surface or anything. The datum D is connected to the center position, the axis, datum D. No, sir, datum D is axis. How do I measure datum D? That is the next question. So what we do is, in order to come to the center, that 47.6, what I will do is, I will explain to you. If we put this into a milling machine, what I'm trying to do is, I will put a dial gauge holder into the milling machine. Okay, dial gauge holder. And the dial gauge is set to 0.04. That is a limit. Now I am going to dial the inside of the hole. I mean, like rotation inside of the hole. Okay. So if I say that, okay, it is 0.04, within the 0.04, that means by the center axis of my machine is lying within the tolerance. Now I will remove the dial gauge holder and the dial gauge, move the machine to the left, 47.6. So that is how I am taking this datum D. Okay, somebody might ask me, the datum D is just a imaginary axis. How do we take it? So in practical sense, what we do, we dial the inner surface of the hole, and we see that is it 0.04. Okay, it will be 0.04 because we are given the position tolerance. Okay, from that position, we move the axis of the machine to the left side, which will be taken as reference. Yes, somebody is asking me where to use LMC condition. Least metal condition is used when, see, suppose when you are doing in casting and all, you are done a casting, okay? You have done a casting, and then after casting, you have to make some holes for putting screws or anything. Now, least metal condition, if you are not using there, what happens is the wall thickness will be eaten off. The least metal condition means the least metal should be there on that particular periphery of the casting. If it is not there, what happens is when you try to drill there, one of the walls can get opened up. So LMC is used only. LMC is not majorly used, but I'm telling you where it is used. It is used in the casting other process where the wall thickness is maintained. You want the wall thickness to be maintained. So in that case, the LMC plays important role. Okay, so a lot of questions here. I will try to arrange a forum and try, because these are all listed. We'll put it on a forum and you people can refer it.